Hello friends, welcome to Shiksharthi. In this video, we'll be solving questions of exercise 7.4 on coordinate geometry. So let's start. Talking about question number 5. Now as I read the question, this question looks to be slightly difficult, but on a second thought, maybe it is not. So in short, the question initially starts off with when you shift the origin. The question is basically on how to shift the origin. Now origin we in any case know is 0, 0. So if we are able to ascertain the points P, Q, R. So there is a triangle that they have made. So if we are able to ascertain the coordinates of P, Q, R given the existing axis. The existing axis is where we are ascertaining the points with respect to 0, 0. So PQR is what they have given to you like this. When the origin, let's say, is O. Right? So can we ascertain the points? We can. So if I see the coordinates of P, can I say are the coordinates are 4, 6. So I'm writing it down here. So let's say P is 4, 6. Now Q and then R. So Q is 3, 2, and talking about R is given to you as 6, 5. Now this is when the origin was O. Now the origin is being shifted to D. You're shifting the origin to C, sorry. So when you're shifting the origin to C, now let us first find out the coordinates of C as it is. So the coordinates of C, can I say, are nothing but 11, 12, 13, 14, 15, 16 is the X coordinate, and talking about the Y coordinate is 1, 2, 3, 4, 5, 6, 7, 8. So can I say that now here the origin was 0, 0, and now C is what? 16, 8. Okay. Now the origin is shifted from this point to this point. That means now you have to see it relatively. How much would the points shift relatively? Okay. Now, how to attempt this question? So now in this case, when the points were 0, 0, what was the difference between the X coordinates of, let's say, R? The difference here was, we knew that this is 6, and just by the side of this, so how can R be 6 in this case? Hold on. Okay, R is 6. PQR. I have done the nomenclature incorrect, I think. Yeah. So this is PQR. Now Q, let's say, is 3. P here is 4. And R here is 6. So we are talking about PQR. Now we are shifting the origin to a point. So now if I shift the origin, now the origin shifts to a point. If I'm just shifting on the x-axis, it shifts to a point which is 16, 0, and then I change the y-axis. So now in this case, I just need to see that from, if I talk about R, which was the closest point, R was the closest point here. So by how much should it shift? And C actually is, now on a second thought, I see that Okay. Okay, so can I say now the R shifts to what? What is the difference here if I see? So when the origin shifts here, it is not the origin that is shifting. So can I say I'll have to shift the entire figure? So if I'm shifting the entire figure, so when the origin shifts, the entire figure shifts. In that case, can I say the difference here was how much? 10. Now if I take half of it, I'm sorry, the difference here was, okay, the difference in the x coordinate was 10. So now here if I see, and the difference between, so can I put it like this? Can I say here now that R, if I talk about the x part, is 10. If I talk about the p part of it, the coordinates of p, the x coordinate of p, can I say it will be a 12? And here this becomes a 13. Now when I see the difference comes out to be, here the difference is 4, here the difference is 10, and here the difference is 8. Now talking about their y coordinate. So when I talk about the y coordinate, can we say that it is, no, in this case it is 2, in this case it becomes 6, and in this case it becomes 3. Let me check this question once again, and by that time just check that whatever we have done, is it correct or not. So please mind it that we are talking about part 2. So this was part 1, and this we are talking about part 2. So the ultimate coordinates that I get from here are 12,2, 13,6 and 10,3 is what we get. Now they are asking you also calculate the areas of these triangles. What do you observe? Now I am shifting the figure. The area is independent of the shifting of the figure. So the area in any case is going to remain the same. So using the formula of area, wherein I know the coordinates, so I can say area is half times of x1, which is 4, into y2 minus y3, which is minus 3, plus x2, which is 3, into how much? y3 minus y1, which is minus 1, plus the last part of it here, which is 6, into y1 minus y2, which is 4. So 24 minus 3 is 21, 21 minus, now this comes out to be a 12, which is 9. So can I say this is 9 by 2 square units? Yes. Moving on to the next question, which is question number 5. Talking about question number 5, I'm sorry, this was question number 4, and now we are going to talk about question number 6. I'm so sorry. So question number 6, it says the vertices of the triangle are given to you and a line is drawn which intersects the sides. Okay, instead of solving it here, maybe I solve it here so that you are able to have a better look at it. ABC. And there are 2 points, let's say D and E, such that if this is x, this entire part is 3x, and this entire part is 4x. If this is y, the remaining part here is 3y. If this is z, the total part will be 4z. I am using the information which is given in the question. The only thing which I have not written here are the coordinates. So if I write down the coordinates, 4, 6, followed by B, which is 1, 5, followed by C, which is 7, 2. All I need to find out here is again the area, and I need to relate. Now since, if I just use a theorem of geometry, which is the section formula or the midpoint theorem, is nothing but the same. So in geometry, what we call it as basic proportionality theorem. In coordinate geometry, it becomes the section formula. So using the section formula here, can I say now this, the coordinates, we know that this ratio is 1:3, right? So m1 into x2, which is 7 plus 12 makes it 19. So this becomes 19 by 2. 2 plus 18, I'm sorry, this is 19 by 4. So 2 plus 18 makes it 20. And here in this case I can say 1 plus 12 makes it 13. So 13 by 4, comma 5 plus 18. So 5 plus 18 is 23 by 4. I can find out the area of this triangle, I can find out the area of this triangle, and then correlate between the two. But since I know geometry as well, so can we say that the area of the triangle, using geometry, the area of the triangle ADE. Now if I drop a perpendicular from here, and if I take these points as F and this point as G, so can I say the area of the triangle versus the area of the triangle ABC? This is nothing but half into base. So now this is half. Now the base for this is BC into the height, which is AG. Now here the height is AF, which is 1/4 of AG, right? And here talking about the base of this triangle again would be 1/4 of BC. So eventually you will say that the ratio of their areas would be 1/16. So 16 unit square is the area of the triangle ABC. In that case, 1 unit square should be the area of the triangle ADE, which now you can use this formula and you can check whether your answer is correct or not, if we have used these coordinates properly. So we just check these coordinates once again. So once we check these coordinates, we know that this ratio is 1:3. So 7 plus 12, which is 19, 19 divided by 4 is the x part of it, right? 2 plus 18 is 20 divided by 4, which is 5. Now in this case we are saying 1 plus 12, which is 13 divided by 4. 1 into 5 is 5 plus 18, which is 23 divided by 4. So just use this and check, which you will be able to do it yourself. Talking about the last question now, which is question number 7. Okay, now again it talks about a triangle. So let's say there is a triangle ABC. Do we know the coordinates of this triangle ABC? Let's see. So the coordinates are given to you as 4,2, 6,5, and finally as 1,4. Okay. Now the first part here is, this is a pretty interesting question. These kind of questions you have already done, so I don't see any reason why you will not be able to do this. This is a very interesting question. So this should definitely be understood by you. It is not that we are doing it for the very first time, but this is a kind of a snapshot for all your doings of the past. The median from A meets BC at D. Now it is given that this is the median, which means what? So 6 plus 1, 7, 7 divided by 2, 5 plus 4, 9, 9 divided by 2. These are the coordinates for D. And what are they asking you to find out? Are they asking you to find out the coordinates? Yes, which we have found out. So what did we use here? We used the section formula. Okay, talking about question number 2, subpart 2. Find the coordinates of the point P on AD such that AP is to PD is 2:1. So they are basically talking about the centroid. Since we have done geometry, if you have not done geometry, or you do not know the formulas, this gives you a very good opportunity to go through at least the video on medians, so that you are able to understand that the point that P which they have given to you here is nothing but the centroid. What is centroid? Centroid is the intersection point of all the medians drawn inside a triangle. And they are asking to find out the coordinates of P. Okay, so using the section formula, now I can say what? Twice of this, which is 7, plus 4, which is 11, divided by 3, because 2 plus 1. Twice of this, which is 9, 9 plus 2, 11 by 3. And what, I mean, have they asked you to only find out the coordinates of P? Yes, which is 11 by 3 in both the cases. Question, subpart 3. Okay, find the coordinates of the points Q and R on medians B, E and C, F. So before we begin, let me write down the coordinates for this, which is 5 by 2, and this is 3. And the coordinates of F would be 6 plus 4, 10 divided by 2 is 5, 5 plus 2, 7, 7 divided by 2. And you know that here, in this case, this ratio will also be 2:1 and this ratio will also be 2:1. Now what are they asking you to do? Find the coordinates of points Q and R on medians B, E and C, F. B, E, let's say there is a point Q, and R on C, F, such that BQ is to QE. BQ is to QE is 2:1. So in any case, what are they basically talking about? Are they talking about that P is equal to Q is equal to R, because it is only then that the ratio can come out to be 2:1. And they are asking to find out the coordinates of Q and R. So can I say that the coordinates of Q, P and R would be the same, because in any case they happen to be what? Centroid. Had you not known this thing in advance, this becomes slightly difficult, because what is the variety of this question? This is an application based question. What is an application based question? Wherein one topic requires another topic to be integrated with it, which is why this is an application based question. Okay, what do you observe? So we observed what? We observed that in case if BQ is to QE is the same as CR is to RF, is the same as AP is to AD, is the same as 2:1, in that case PQR are not distinct points, they are nothing but the same point. I mean, they converge, they are they are concurrent in the sense P is equal to Q is equal to R. This forms a basis of our this is the conclusion. Okay, let's talk about fifth one. So now talking about the fifth one, it says if A, which is this vertices of, find the coordinates of the centroid. Okay, so this becomes pretty easy. So in this case, actually what did we do? You can take a hint from here itself, or let me say that if I were to just draw a diagram and make you understand, let's say this is x1 comma y1 is what they are asking you to do. This is x2 comma y2, this is x3 comma y3, this is the centroid. Let's say this is A, this is B, this is C. So we know that centroid is nothing but the point of intersection of the medians drawn inside a triangle. So here, can I say this is nothing but x3 plus x2 divided by 2, comma y2 plus y3 divided by 2. I am talking about coordinates of D. Similarly, coordinates of E. And then we'll find out the coordinates of F. And something that is already given to you is the ratio 2:1. So given here is, they have given you AG is to GD is equal to 2:1. At the same time, CG is to GF is also given to you as 2:1, which we did here. And at the same time, BG is to GE is given to you as 2:1. This is already given to you because G is the centroid. Centroid is the point of intersection of all the three medians which are drawn inside a triangle. So in that case, can we find out the coordinates of F? Yes, x1 plus x2 divided by 2. Similarly for Y, y1 plus y2 divided by 2. Similarly for E, which is x1 plus x3 divided by 2. and the y coordinate becomes y1 plus y3 divided by 2. Now once you know this and you know the section formula, so twice of this makes it how much? x2 plus x3, and 1 times of x1, which is x1. So what do we get? The coordinate, the x coordinate comes out to be x1 plus x2 plus x3 divided by 3, and analogously you can write down twice of this, which is y2 plus y3, 1 times of this, which is y1, so y1 plus y2 plus y3 divided by 3. This proves what? This is something that we have been saying time and again. Please take theorems as questions rather than taking questions and then remembering the theorems behind them. In that case, you will never ever forget the theorem which will be used per se. Okay, talking about the last question which we are going to do here, which is question number 8. So question number 8 talks about there is a rectangle which is formed with the help of 4 points. Let's say A, B, C, D. The coordinates here are given as minus 1 comma 1, I'm sorry, minus 1 comma minus 1, minus 1 comma 4, right? Okay. Instead of taking it like this, it will be better if I take the other coordinate. Let me put this as, this is point B. What is the reason behind? The reason behind it is to make it come close to as original as possible. I mean, for example, I know that the coordinate of B is minus 1 comma 4. So I know that at least this should have come above. So all now I can do a change here is, maybe I take A here, B here, C here, D here, that I can do. But anyway, this still looks to be real. Point number C is given to you as 5 comma 4, again which looks to be real because here the y component is the same. And D is given to you as 5 comma minus 1, which again looks to be real. Though the exact should have been BC should go up and AD should come down, but now it does not make much of a difference. Then they have given you the midpoints of AB, BC. So AB, P, Q, R, S. Now if you know in advance what is the resultant figure that you are going to get, it will be very good. For this, if you can just watch the videos that I have already done on geometry, it makes sense. So maybe if I were to guess, this is a rhombus. It's not because it looks like a rhombus, but anyway. So can I find out so once I know that these are the midpoints, can I find out the coordinates for S? Let me write down the coordinates separately, P, Q, R, S. So the coordinates for P would be what? Minus 1, comma, 3 by 2. The coordinates for Q would be what? 2, comma, 4. For R, it will be 5, comma, 3 by 2. And for S, it will be 2, comma, minus 1. What are they asking you to find out? Is this quadrilateral PQRS a square or rhombus? Justify your answer. A few minutes back I spoke about something. Now if this had to be a square, let's say this had to be a square or this had to be a rhombus, we know that there is some amount of similarity, let's say more similarity than the dissimilarity between a rhombus and a square. Now for a square and a rhombus, the similar part is all the 4 sides would be equal and their diagonals would bisect each other. So don't use this. Let's use the differentiating factor. The differentiating factor here would be, I know that the vertex angle of a square, any vertex angle would be equal to a 90 degrees. But in case of a rhombus, it will not be equal to a 90 degrees. Second thing that you can do here is either you take this, which is the slope concept. So in that case, we will find out the slope for SP and we'll find out the slope for SR, and the product of this should not be equal to a minus 1 because we know for 2 perpendicular lines, the product of their slopes will be equal to a minus 1. This is one side of it. Another side of it is use the distance formula and prove that SQ is either equal to SPR. If it is equal to a PR, then it is a square, else it is a rhombus. So since I had told you at the very outset it is a rhombus, so either I use this property or I use the distance formula. Choice is yours, whichever you feel is easier for you. So if I were to use the distance formula, so what is the distance SQ? SQ is 2 minus 2, which is 0, and this comes out to be 5. Now this should not be equal to PR. Now PR is how much? 2 minus or minus 1, which is 3 square, which is 9, plus minus 1 and minus 1.5, which is minus 1 and minus 1.5 is minus 2.5. Minus 2.5 whole square is 6.25. So now this comes out to be under root of 15.25, which they are not equal. Hence it proves what? It is a rhombus. Had I used the slope method, that also you can do. Now if you calculate the slope for SP, SP is y2 SP. So y2 minus y1, which is just like saying 2.5 divided by, so y2 minus y1 divided by minus 3. SR, let us find it out. So 4 minus of minus 1, which is 5, right? 5 divided by 0. So if I multiply, so this itself, if I find out the slope of this line, which line slope am I trying to calculate here? We are trying to calculate the slope of the line SR. Oh, we did this incorrectly. So now when we find out the slope of SR, this is 2.5 upon 3. Oh, have we done it correctly? Let's see. Now in that case, SP, we are doing what? This minus this upon, so when I multiply these two together, it does not give you. So slope of these two, so slope of SP, line segment SP, and the slope of the line segment SR is not equal to minus 1, which also proves that it is a rhombus, right? If you feel that this video will really help you, or it has helped you a lot in terms of improving your knowledge quotient, please do not forget to like, share and subscribe to our channel. If you have already done so, click on the bell icon and select all, so that you get regular updates from us. If you want us to do videos on some specific topics, don't hesitate and put it in the comment section so that we can do it for you. Thank you so much. Until next we meet, goodbye.